So this is the year 12 higher level paper 1b. We're now on to question 4. The graph is quite large, and so I've just reduced the screen area just a little bit so we'll be able to see it in a moment. So let's just extract from the stem. So we're talking about a well-trained runner, and we're making two measurements, one of ventilation rate, number of breaths per minute, and tidal volume. So that would be measured in liters per breath. So if I just move the graph, and they're on a treadmill, and the treadmill speed is being increased. Okay, I think we can hold it just there, and we'll be able to start. Okay, so along the base here, along the x-axis, we have treadmill speed. So clearly this has been done at a number of different speeds of the treadmill. And the ventilation rate is on the x-axis left-hand side with breaths per minute. And then we've got this double use of the y-axis with tidal volume in liters per breath on the right-hand side of the y-axis. Okay, the data then, the diamonds are the tidal volume. Let's just put that on there to remind ourselves. And then this is ventilation rate. So let's look at the pattern. It's always worth just spending a few moments looking at the pattern and thinking about what's there before getting into the meat of the question. It does help to condition your thinking. And so I can see a pattern going up and perhaps a slight easing off, perhaps. And then almost the opposite here, as this goes like this pattern, and then it picks up this way. Okay, so perhaps that will come into our question. Let's take a look at the first question. And this is a state question, so we probably just need to give a name. State the apparatus used to measure the tidal volume. Okay, so this will be a spirometer. They come in all shapes and sizes, and hopefully you've had a chance to see some of those in the laboratory, and we'll see some later on during the course as well. Okay, so that's that question out of the way. Now we're required to do a calculation, so we're going to have to go back to the graph of the total volume of air inhaled in 1 minute at the highest velocity of the treadmill. So what we're going to have to do is we're going to have to multiply the breaths per minute, the ventilation rate, multiply that by the tidal volume. So we need to find these two values, and remember it's at the highest velocity of the treadmill. So let's go take a look back at that. Apologies for scrolling. So the highest plotted data of the highest speed of the treadmill is here. Now this doesn't mean that these are the highest values, it means that this is the highest speed of the treadmill. And so we have these two values here. So that one there is a tidal volume, and that's measured on this side here. So we take a look at that. 25 would be here. Now, I would strongly recommend to candidates that where you're trying to determine these values, that you take a ruler and you determine much more precisely than I just did the actual value. And this is what the IB expects, that a guesstimate is not really good enough. I've done this with a ruler already, and I'm actually thinking it's 2.48, and that would be liters per breath. So then up here I have the value for the maximum treadmill speed. I've got the value for the ventilation rate, and again one needs to get the ruler on this to draw a horizontal line that goes across like this, conveniently goes through the text like so, and takes me, I measured this at 75 ventilations per minute. So it's 2.48 and 75. So let's go back to our number of breaths per minute, tidal volume. We need to put those into the calculation. So the tidal volume will go in at 2.48 and the number of breaths will go in at 75. Get your calculator out and do the calculation, and you should come up with a value of about 186. Now the units would be liters per minute. You may put that as liters per minute -1. That's an alternative way of expressing that. So this is the value that we're looking for. And then to the final part of this question, it says compare and contrast the effect of increased treadmill speed on ventilation rate and tidal volume. So we've actually come to back to the graph, and now we're looking at patterns. It's important when you do this to almost state the obvious to start with. And so if we begin with as the treadmill speed increases, I'm sure you'll do a better job at laying out than I'm doing here, then state the obvious that both the ventilation rate and the tidal volume, they both increase. So that would certainly attract a mark. But we're looking for a second one. So the one I noticed was that for low speeds, the tidal volume increased faster than the ventilation rate. So that's a possible one there. I also noticed, and you may have picked up this one as well, that the tidal volume actually seems to have a plateau. So you may choose to put one of those in. With this one, you could do the reciprocal of that as an argument as well. So 2 of those will take us to the final 5 marks of this question.